Hello, this week we will continue with Python. We will do a little bit of if statements and loops, and we will end with some functions. There is an online book that you can look at, a little interactive. There's a link published in the slides, or you can Google it. It lets you try some of the things online. I highly recommend. Best way to learn is to practice. So if you practice, it will be better. The first topic will be basic Boolean expressions. So what I would like to do is decide if things are true or not. And so Boolean expression is something that if you evaluate it, it will say yes, no, or true, false. In our case, true, false. Okay? There are different operations. If I have two variables, x and y, and I would like to compare if x is equal to y, you can do it with x equal y. There are two equal signs because one equal sign was for assignment. So you need two equal signs to get the comparing the values. If you want to say not equal, then you write exclamation equal. If you have numerical values, you can do comparing. So you can write x equals y or x less than y. If you want to say greater or equal, then you first write greater and then you add equal. Less or equal, then first you do less and then equal. You can also do comparison that you say x is between y is between x and x plus 2. So you write x is less or equal than y, and y is less or equal than x plus 2. Those are basic operation for x and y if x and y are numbers. You can also try to do test if x is part of a list. So you write x in and you write the list. The list doesn't have to be written explicitly, it can also be a variable, or you can say x not in a list. So if you want to check if x is not in a list. First, experiment with some basic Boolean expressions. So we can have something like 3 equal 4. If I execute it, it says false because 3 is not equal 4. How about 3 equals 3? It's true. Okay? You can write 3 is not equal to 3. This is test if, okay, maybe I should do it like this. 3 equals 4. False. 3 equals 3. True. 3 is not equal to 3. False. 3 not equals to 4. True. How about 5 bigger than 7? Is it true or not? This is false. 5 less than 7. This is true. 5 less or equal than 5 less or equal than 6. True. 5 less or equal than 5. True. About 3 less or equal than 5 less or equal than 7. True. About 3. True. How about 3 less or equal than 5 less or equal than 4? It is false. And we can try also on the lower side. 6 less or equal than 5 less or equal than 7. This is also false. So if you chain the inequalities after each other, you can see how you have to satisfy both of them. We had to test if something is in a list. So let's say 3, 4. Is it true that 4 is in the list 3, 5, 6, 7? False. Is it true that 4 not in the list 3, 5, 6, 7, true. We could also say 4 in the list 3, 4, 5, true. And 4 not in 3, 4, 5. This is false. So here we went through all the basic operators. So you have these basic things that do true and false, and then you can put them together in a bigger statements using and or and not. So if you want to say that something is true and something else is true, then you write x and y, where x can be a variable that is true or false, or it can be an expression. If you write it as an expression, sometimes you may need to put parentheses around to make sure that the priority of the operations is preserved. So there is an and, which is true only if and only if both x and y is true, or if at least one of x and y is true. And then there is not x, which is a negation of x. Not x is true if x is false. Expressions using and or. So let's try 3 less than 4. This is true. And I say I want to be 3 less than 4, and at the same time I would like 4 less than 5. And what is to happen is that both of these must be satisfied. So if I write here that only the first one is satisfied and the other one is not, then this is false. If both of them were satisfied, then this was true. True. Both must be true. Both must be true. True. Maybe capital T. Okay? And then there is or 3 less than 4, or 4 less than 3. This is true. At least one is true, or 3 less than 4, and or 4 less than 5. This is still true because at least one of them is true, right? You can also write not. So 3 less than 4. This is true. If you write not, then this is false. Negation changes true to false and false to true. So this one is false, and if I have not, 3 is less than 2. Now this is true. So this is a way how you can combine different logical expression. You can of course make more complicated thing by using and or inside these parts as well, and using parentheses to say which and or comes first and which comes second. And or is that it tests only the smallest amount you really need to know to figure out if the result is true or false. So for example, I will try to write here something like if I have 3 less than 4, or 5 less than 7. So when this is being evaluated, the 3 less than 4 is tested and the 5 less than 7 is not tested at all. Right? I will demonstrate how this is happening. So let's say I will have here 5 divided by 0. Right? What happens if you call 5 divided by 0? Then you get error. the division by 0. So if you have division by 0, things go bad, right? So here this causes error. Causes error, so I'll comment it out. And here I will say 5 divided by 0. And the expression is still true, because the 3 less than 4 was evaluated as true, and then this second one was not evaluated at all, right? How about I change it to 3 bigger than 4? Then we get the 0 division error, because 3 bigger than 4 is not true, so this evaluated as false. And then the Python was trying to say, I can still satisfy the whole expression by testing the second part, and if you test the second part, you have to evaluate 5 divided by 0, and then the thing collapses, right? So why is it useful, this thing? So this thing is useful if you have tests that are easy and difficult, and then first you ask for the easy test, and if the easy test works, then you are done and you don't have to ask for the difficult test, right? So I would like to write something like easy test or hard test, right? So this is how you can save time. If you write it the other way, hard test, that takes a lot of time and effort, or easy test, this will always execute the hard test, and if the hard test fails, then it does the easy test. So here, hard test run, hard test used only if easy test is false. Okay? So good to be aware that the order in which you put things in the OR matters, right? First you put the easy thing to test, and then you put the hard thing to test, right? And with the and clauses, it allows you to do also fun things, right? So let me maybe I will try to do the following test. I will write x3, and I would like to know if let's say y equals 10, and I would like to test is y divided by x at least 2, right? I have to comment this thing out, sorry, right? Y divided by x at least 2, yes, y divided by x is bigger than 2. And I can try to change the x and y, right? Now it is false because 7 divided by 4, it's integer division, it's less than 2. And now what if I write here x equals 0? Okay? Now this thing fails. So what you can do is you can write a constraint that this works only if x is not equal to 0. So you write x is not equal to 0 and y divided x is bigger than 2. And now this is false, right? So what happened is first we test if x is not 0, and if x is 0, then we already evaluate the whole thing as false, and the second part is not tested at all, right? So here I have let's say necessary constraint, and test, right? So you can test that or necessary constraint or assumption. Okay? So I have an assumption that x is not equal to 0. First I test if x is not equal to 0, and only if x is not equal to 0 I evaluate the actual test, right? This is a nice way how you can make sure that if you have some input that goes to the second part, and the input must satisfy some obvious constraint, you test for the constraints over here, right? The next construct is if then else. If then else will let you test a condition and then do some comments if it is true, and possibly do different comments if the condition is false. Here is a section 7 reading. Look at the section 7 from the book. here is a example how it is written in the code. So you have the if, then you write Boolean expression, then you write colon, and then you have a block of code that is indented. In the example here is statement 1, but there may be many statements, not just one, and that happens if the Boolean expression is true. Then there is else, which is another branch. If the expression is false, then whatever is statement 2, possibly more statements get executed. You can look at the diagram on the right that somewhat describes what is happening. The program execution starts on the top and arrives to the condition. At the condition, this gets evaluated and you get true or false. If the condition is true, you continue to the right, execute statement 1. If the condition is false, you move to the left, execute statement 2, and then both of the execution branches join and the program continues below. For if and else, so here I write if. Now I have to write a Boolean expression. I can write here true, or I can write here some actual condition. I do not need the parentheses. Then you write colon, and here you have a block of indented code. So here I will print block 1. You can write more things if you want. Hello, expression was true. Here else, have to go back under the if. If you keep it like this, things will not work. I'll show you, of course. Print block 2. If we execute it, 4 is less than 5, so we go through the block 1, and this is being skipped. Maybe I'll print done, and done will be in any case printed, right? If I indent this a little bit, then I get the syntax error because this else need to be indented the same way as the if I flip the constraint, then 4 bigger than 5 is false. So instead of doing the first block of statement, the second block is done. And notice it stops the block when I indent back to the original indentation line, right? So the else, if, and this P are on the same column, and then this P and P are on the same columns. I can have them like this, and then I will get an error because they are not indented the same way. But if I both indent them a little bit more, it's okay, as long as they are indented the same, right? So here one has to be careful about the indentation. It is possible to omit the else part if you are only looking forward to the case where Boolean expression is true. So you can write if Boolean expression, and then you indent on the next line and write what statement you want to execute, and then the else is not there. If you want to do only the else part, you need to still create the commands for the true condition. You cannot just write if and immediately follow by else. But what you can do is use this keyword pass, and pass is saying don't do anything. But the pass will allow you to create a block of code that doesn't do anything, but it must be there in order for the Python to compile your code. Need the else part. You can just write if is less than 5, print 4 is less than 5 is true, and then when you are done, you can with the statements in the if, you just write done. Okay? You indent back. And this will do 4 less than 5 is true, and done. I will write for bigger than 5. For bigger than 5 is true. And now this is evaluated to false, so this block of code is skipped, and then it continues with the code that is indented the same way as the if indented. So yeah, I will move it like this. It's harder to do only else parts. So right, if, maybe I'll check this. If 4 is less than 5, else print hello. Not. Maybe first write like this. So now it is saying it expected that there is a block of code that is indented after the if statement. And the else is the same in depth of indentation after. So you need to write here something. Right? You can write 5. Now this is a string that says 5 and does nothing. But, so for Python doesn't matter, but maybe for people who want to read the code after you would like to have maybe for greater than 5, then the else will happen. Okay? You want to show them that you know that nothing should happen. This needs to be here, but does not do anything, except it lets you write the else part and skip the if part. Okay. It's of course possible to nest the conditions. So if you have one if condition, if x is less than y, then it prints x is less than y, and then there is the else statement, and in the else statements there is another if condition. It now tests if x is bigger than y, and then it writes x is greater than y. And then if the first condition is false and the second condition is false, it means that x and y must be equal. So that comes to the last condition. Okay. You can also see the diagram how the code runs on the right. It first evaluates the first condition. If true, it goes to the right to statement 0. If false, goes to the other statement where it's check if x is bigger than 0, and then you have again true or false. Write if conditions inside the if conditions. So here I'll try to do some code that decides if x is less than y, equal to y, or bigger than y. So I write x, it will be some number 5, y 7, and now I will do some tests. Alright, if x is less than 7, or less than y, then now I have indented code, print x is less than y. Right. Else. Right, so now I know that x is not less than y. So I will try to do if x is bigger than y, then print x is bigger than y. Maybe I can try it, what it does. It says x is less than y. Alright, it was good. If I write here 8, prints x is bigger than y. If I write both of them the 7, doesn't say anything. So maybe I can write it else. One more statement. Print x must be equal to y. And now we have a piece of code that will print if x is bigger than y, or if it is less than y, or if they are the same. You can make this thing a little bit nicer, that you have first the if condition, if x is less than y, which is the same as was before, and then in the second branch you would like to write else, if, and else. So you can write elif, so it is combining the else and if together, especially if you have many of these conditions that you would like to put after each other. If, else if, else if, else if, else if. This makes life a little bit easier because you don't have to keep indenting things, and a little bit easier to read. It calculates what is x mod 3. Let's say I have x, it will be some number, and now I will try to calculate what is x mod 3. So if x mod 3 equals 0, then I can write print x mod 3 is 0. Yeah. Didn't print anything. X mod 3 is 0. Alright, good. So and now we could write else, and if x mod 3 equals 1, I could write x mod 3 equals 1. So if I put here 7, it should be that it goes this branch, it skips and it goes here. To make life a little bit easier, what one could do is one could do elif, and is equivalent to the previous code, just a little bit shorter. We have one less line and it looks a little bit less indented. And you can add one more else, and now x mod 3 is 2, 7, 8, print, done, and the done will be printed in any case. 8, 9 should be divisible, then mod is 1. Okay. So the elif here allowed us to make it slightly less indented, a little bit easier to read. Here a little bit of code. So I have a code where I have input. As input I get some temperature, and I would like to say if the temperature is bigger than 90, that we will print it is hot outside, and if the temperature is not more than 90, then it prints it is not hot outside, right? So let's try to run it. Right now it copies this string, writes it here, and lets me write here something. So what if I write that the temperature is 32? Is it hot outside or not? We have an error. What happens? So here it shows us it is on this line is the error, and what does it say? Type error, bigger is not supported between instances of string and integer. So what happens is that this input gives you string, and before you compare it with a number, you have to convert it to a number. So we can try to do something like this. Write float, try it again, temperature 89. It's not hot outside. We can try it again. Temperature 99. It is hot outside. Okay? So one has to be careful that if you do comparison, that you do it with the same types. Loops are pieces of code that you can execute over and over until some condition is satisfied, typically. There are two basic loops, for loops and while loop. You can read about them in section 4 and 8. Let's start with for loop. For loop is loop that has one variable that you call name, and then you put in list of possible values for name, and then the variable name will go through all the entries in the list. So the name will be first Joe, then it will be Amy, and then it will be Brett, and it will execute the code that is under the for loop. The code that is under the for loop is indented, so in this case it will print, "Hi Joe, please come to my party. Hi Amy, please come to my party. Hi Brett, please come to my party." And when name iterates through all the entries in the list, the code continues below the for loop. Over several entries in a list. So you want to create a list for, let's say, name in, it was the keywords, the for has to be there always, it has to be there. The name, you can write whatever name of the variable you like. Here, list or something that generates one. Here I write Joe, Amy, Brett, and here I want to write print. Let's first print just name, right? And then the name, variable name, first it is Joe, then it is Amy, then it is Brett, and it always executes this line. Right? If I want to make here a little bit more, hi, oh maybe hi, name, come to my party. Oh, hey Joe, maybe the space here is not best, I'll delete it. Hey Joe, come to my party. And if you can write more commands here, for example, you can write just empty lines so it's separated by lines. Okay? Here what you can do, of course, is to have the list of names separately, and then you can iterate over the list of names as a variable, right? And the list can have anything that can be printed. Well, now it doesn't make as much sense, but this is a demonstration, right? If you want to have also the index of them, then what you can do is you can do something like name, and here you write enumerate, and here you can print hi name, you are number I. Okay. And here, hi Joe, you are number 0. Hi Amy, you are number 1. So the I will give you the index 0, 1, 2, 3, 4, and then the name will give you the entry in the list. Sometimes it's useful to know what's the index in the list as well. While statement is a statement that doesn't necessarily have fixed number of iterations to begin with. It's controlled by a Boolean expression. So you have to write while Boolean expression, and then you have block of indented code. And as long as the condition is satisfied, the block of the indented code executes, and then the condition is tested again. So in this case, we start with n equals 10, answer equals 1. And as long as n is bigger than 1, we keep doing the following two things. First, we add n to the answer, and we decrease n by 1. And then we keep doing this and keep doing this as long as n is bigger than 0. If you mess it up in this piece of code, if you write n equals n plus 1 instead of n equals n minus 1, then n starts at 10 and it will be increasing in every time you go through the block. It will just go up and up and up. So this while loop will never end. You will create a loop that makes the computer run forever or until some overflow happens. So in this case you have to be a little bit more careful to make sure that you don't create infinite loop. Creating a loop that can run as long as condition is satisfied, or maybe it can run forever. So let's do here a little experiment. I will have n equals 10 and here's some variable answer 1, and now while we'll start the loop, and here I write the condition, and as long as the condition is satisfied, then I will increment the answer by n. Answer is answer plus n, and decrease n by 1, and then print answer. Okay. Right. Now if it runs, then in each iteration here answer increases by n and n decreases by 1. So this is summing numbers. So we can actually print them. Print here I will n answer. So it says if at the beginning n is 10 and answer starts at 1, then answer gets increased by 10 and n decreases by 1, and the condition tests again, and we go to the next round, and slowly the n is decreasing and the answer is increasing. So this is summing out numbers 1 up to 10. Okay? Right. So what can happen here is two things I wanted to show. One is how to make this little shorter. So if you have something like this, you can write answer plus equals n. So now you are adding to answer n. This is little called syntactic sugar. Okay? And same with this n, you can write n equals n minus equals 1. So I'm subtracting 1 from n, and the program runs the same way as before. Sometimes these are easier to read, sometimes this whatever you like. Right. And here is the thing: if you have a condition that is always true, this never stops. So here we can make a easy condition that's always true while n is bigger than 1, or true. Right? If I write here or true, this will eventually stop being satisfied, but the whole thing will be satisfied because there is the or condition and true. And if you run this, then you see how n is getting smaller and smaller, the answer is getting smaller and smaller. Now this loop will not finish. You need to press this stop to interrupt the loop. Right? Otherwise it will keep running. Now your keyboard interrupt. You can scroll through the whole thing as long as you like. Okay? So careful if you have a loop that doesn't finish is while you may have to stop it a little bit. Break and continue are ways how you can control how the loop runs a little bit better or more precise. So here is the first one, break. If you put it somewhere in the loop, then the moment the break happens, is encountered, the loop execution is stopped and the program will continue in the block after the loop. So in the example on the left, the program keeps running inside the loop, and the x is increasing, and eventually when x is equal to 5, the break is encountered and it says stop the execution of the whole loop and continue after the loop. The other thing that you can use to control how the program runs in the loop is continue. What continue does is that it interrupts the current iteration of the loop and goes back to the next iteration in the loop. Okay? If you have a for loop, then what it does is that it stops processing current x and start processing the next x in the list of things in the for loop. If you do it with the continue in while loop, then it will go back to evaluating the constraint in the loop and starts the loop from the top. Here on the right there is a command for x in range 0,7. It means that x will go from 0 included to 7 excluded, and it will be step 1 integers. So in this case range 0,7 in the for loop will make the for loop go over 0, 1, 2, 3, 4, 5 and 6. Little piece of code that will demonstrate how break works. I'll create a variable 1 and then I will do while x less than 7, then print x and I increase x by 1. Okay? Right, so this will write numbers 1, 2, 3, 4, 5, 6 as the loop runs. Whenever the number gets here x, then I increase it by 1, and this condition stops being true when x gets to be 7. Print done. Right, so what we can do is include the here break. We'll do if x is equal to 5, then break has to be indented. It's a block of code in the x equals something. And now when x is equal to 5, this x equals 5 will be true, and we will hit this break, and the break will jump here. We'll jump here. Okay. So we do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and whenever x is 5, the loop gets interrupted and continues here after the loop. Okay? So it's a way how you can get out of the loop quickly if you need to. A for loop to print numbers from 0 to 6, but we will skip number 5. Right, so first I'll try to get the numbers. So let's see what we can do here. There is a function range that is creating numbers from 0 to 7, but 0 is included and 7 is not included. So included. If you want to see them, you can ask to list them, and now it will create it as a list. So list 0, 1, 2, 3, 4, 5, 6. Right, you can use range in for loop. So let's try to do for x in range 0, 7 print x. Right. So now we printed numbers 0, 1, 2, 3, 4, 5, 6. And I would like to not print the number 5. How to not print the number 5? So we'll do here and say if you could do it like this: if x is not equal 5, then I print, right, everything. But maybe there are more things that we need to do, and so what you can try to do is if x equals 5, then we write continue here, and then continue will move on, do not execute anything below in the for loop, and get next x. So when x is equal to 5, this will evaluate true, and this continue is telling the Python that you do not want to continue here below, but you want to continue with the next x in the range. Right? A little fun example. So here is how it is going. You will try to estimate retirement balance. Maybe it's a little bit too early for you to think about your retirement. I think this is fun thing to see. Right. So what are our variables that we are looking at? So we have yearly interest rate, or maybe you can think of it is how much the stocks will earn every year, or whatever you invest your money in. Then there is number of years, how many years you are planning to be invested. Then C is how many do you contribute every year, what's your annual contribution. And then there is AUM, asset under management fee. Some companies charge you asset under management fee, which is way how you pay for their service. So here is a question: how much money I will have after Y years if I contribute C every year and the compound interest is P every year? How much will it change if you have to pay some asset under management fee? So here are some assumptions. Let's assume that there is no inflation and the interest rate is 3% annual. So here is it in the Python code. So here is interest 3%, 3 years, 30 contribution 30,000. You can change it to whatever number you want. If you have IRA, maybe 6,000. Okay. And you will try to write the code. Alright, so I will try to write here balance. This is how much money we will have. And then we will do for comparison balance, no asset under management. So this is a balance where we ignore how much we are going to pay in asset under management. Right. So how is it going to go for Y in range years? So now Y will go through 0, 1, 2, 3, 4 up to 29, so it will repeat 30 times. You will not really use the variable Y much, but it will be entertaining. So now, how will the balance change? We will do it in a simple way. So the balance every year grows by the interest. So one would write here, I need to multiply it by, now the interest is in 3, but 3%, so it's interest over 100, right? And if I want to do the multiplication with it, I will do it like this, right? So this is what? This is 103%, right? All right, or you can write it as 100 plus interest over 100. It's the same thing. I'll keep it this because it's easier for me to think about it like that. Right. Then also changes, I'm adding to it the contribution, and then we are removing the asset under management fee. So how is the asset under management fee? So it is 1.2%. So, or maybe we can write it like this, minus equals balance times and asset under management fee over 100, right? And we can do print for the year balance. Now for every year we will see what is the balance. Let's see if it worked. So at year 0 we have here well, we subtracted the asset under management fee, and then it's slowly starting to grow, and after 30 years we have 231,000. Maybe I can write it as integer. Okay? It will be a little bit easier to see. Right. How much did it cost us to have the asset under management fee? I will do the same thing for balance with no asset under management fee, and we'll see. So here the difference is 6%. Oh, 3. It was the asset management 1.2%, 1.2%. And then it is changing, and after 30 years, the difference was 50,000. 50,000 difference, almost 45,000 difference. And you were contributing 6,000 a year. 45,000, it's almost 7 years you were paying for the service of asset under management. 7 years out of those 30, the contribution is just gone. Right? Maybe we can also have here, I will try to print fee. How much is the fee? Is the difference between the asset now under management and under management. Yeah. So now 53,000. So maybe if I miscalculated. Let's see if you were putting in 10,000 a year. Okay. Then the difference is almost 90,000. Almost $90,000 you just threw away by paying high asset under management. Maybe it's 1%, about 1%. 1% doesn't look like much, but 1% is still 76,000. 76,000 over 30 years. Right? About 0.5%. You pay 0.5% asset under management fee. It is still 40,000. 4 years out of your work, of your contributions, is the fee. The fee is really high, in my opinion. Here's a thing that we encountered before, just for a little bit, and that is how to make a list of things. Okay? So here, if you want to make a list of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can use the range function that will create a range from 0 to 9, where 9 is included there, and then you can convert it into lists. Okay, so now I have my list of these, and then what one could do is say, now I want to go using for loop through the X, and then in my list squares, I'm trying to create list of squares. I will append y square. So it's a way how you can do it with like a for loop if you want. Right? Another way you can do it is you can try to compress kind of the lines for y in x square append y times y to like one line way of constructing a list. is a very cute way of constructing list in Python, where you said squares equals, and now you put that square brackets, which says I want to do a list, and then you say what are the entries in the list. In this case, the entries in the list is y times y, which is y square, and then after you have the expression that creates each entry in the list, you create a for loop. So here I am saying for y in range 9. So this will create variable y that goes from 0 to 9 inclusive, iterates between 0 and 9, and for each y it calculates the y square and puts it into the list. There is also a general form of this where you can say that some list that you are creating equals, now square brackets, f of x. X is whatever function you want. The output of this function will be entries of the list, and then you write for x in some list or range or whatever. You iterate x over something, and you can add a condition that you want to use x only if something particular holds. So if a particular condition holds. So this allows you to create lists in one line, where if you would like to write it as in the very first example on the left top, it could take you 4 lines that you first create the empty list, then you do for x that goes through some list, and then you have the if statement. If x is equal to something, then to the list you do append. Some lists. So first I try to make a list using a range. I can write the range 10 will be from 0 to 10. If I make it a list like this, now I have a list 0 up to 9. I can save it into variable x. If I want to check what it is, write print x. Now I see what x is. Right. Now if I try to use the next cell here, then x already exists from the previous cell, so I can use x, and I will try to make squares of x. So what we can do is squares, make a list of squares. Now it's empty, and now I go through every entry in x. So for y in x, we'll be looping 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then into the squares I append y times y, right? Or you can append there y squared. Either way, then I will do print squares. Right? So now I have the squares of the numbers that were in the list x. If you want, you can print x in squares, so you see how it is, maybe y in squares. So now you see how the list is being built one entry at a time. Maybe I'll comment this out to save a little bit of space. Right. Things like this that you construct a list with squares and append are kind of common, and Python has a very nice notation for it that makes life much easier. So what you can do, you can write squares equals, and now here is the parentheses, and here I write y times y, the same thing that I'm appending over here, and here I write for y in x. So it somehow takes this piece of code and collapses it into one line. Print squares. Ta-da! Does the same thing, that it's a nicer notation in doing the extra for loop on the outside. Okay. Right. Here is a addition. Make a list of squares of x for even numbers in x. Right. So first I will do it with a for loop. So again I start with empty list of squares. I will check every entry in X, and I will test if it is even or not. So if the y after division by 2, the remainder is 0, then I will add to the squares y squared. Okay? Here I can do print squares. And now we have squares, but the squares are even because if you have a square that's even, the number you have to start with is even as well. So this is a little test, right? You can do this same thing with a single line like before. So what you can do, you can write squares equal, I will write the old thing first. So I have the y squared for y in X, right? Print squares, pop. So I have all the squares, and now I want to use the y in X only if y mod 2 is 0, so only if y is even. If y mod 2 is 0, too many equality signs, and now I have it as one line. So here you kind of need 4 lines to create the list, and here you can do it nicely in one. Okay? There's one more thing I wanted to show, that is, if you have a list of numbers, you can easily sum them up by calling sum. I can do sum squares, bam, and there is the sum of the squares. Maximum, minimum. So there are these two functions that are quite useful. Max, min, sum. Okay? So you could of course do the max, min and sum with a loop, but writing it like this is faster, and also it's easier for the reader of the program to see what's going on. Functions are great things if you have a piece of code that you want to use at several places or call over and over. Then it's a good idea to separate it into a function. Another way how to use function is you can partition your code into blocks that are a little bit easier to maintain. It also helps you by thinking about how to compose your program together. Online book has chapter on functions that you are welcome to explore. Okay, so how do you make a function, and what is it? So a set function is a sequence of statements. It helps organizing code, prevents code duplication. Right? If you have a piece of code that should do the same thing at several places of your program, it's very tempting to just copy paste it from one part to another. Right? If you do that, it's quick to do. If you need a little change, and then you have to change it in all those places where you copy pasted it, that's very annoying. That's why there are functions. It also helps a little bit with like documentation of the code. Okay? So how do you make a function? It's fairly easy. You write def, that's you are defining thing. Then you write name of the function. It is to start with a letter, and then it can be whatever, maybe. And it has parameters, so you can write several parameters, input parameters, separated by comma. And then you have to write the column at the end of this, and then in indented block you write statements, what the function should be doing, and you keep writing statements as long as you want. And if you want the function to return a value, you write return value. It's optional. Not all functions have to return value. Right? If your function is just printing something, it may just print it and you don't have to worry about returning any value. Example of a function, all it does is it will say hello. Here is a def and let's call the function say hello and print hello. Now I can call say hello and it will print hello, and I can call the function several times and it will be saying hello hello. There can be more than one argument or more than one line in this statement. There can be more arguments. Okay, hello name, and here we can write hello Mark, hello Lucy. So every time you have these arguments here, put it here, and now the name will be Mark, name will be Lucy. So I don't have to copy the first part. If I would like to change it, I can change the function only here and don't have to copy paste it and change it at few different spots. Sometimes functions can return value. If you want to make a function that returns a value, then you use the keyword return, and inside of the function you call return and something, and whatever is the something, that's what being returned. Here is function square. You calculate in the function y and then you return y. So then you can use the square of whatever you want to square as a number that you would use whatever comes from the return. Right? Numbers or whatever else, we'll try to make a function square that will return a square of the parameter. So let's define square of x. I will say y is x times x, so I will calculate the square of x and then I will return y. Okay, and now end of indentation, square 5, so you should get 25. That's a way how you can write the function. The return, whenever you call return, the execution of the function stops and you return the value. You can write here print hello, but the hello will not get printed because the moment you get to the return statement, the value over here is returned. Right? You can make the function a little shorter if you want. You can write the square x and then write return x times x like this, and square 5. So there can be more complicated expression in the return. Okay? Here is a function that is kind of bad. I'll try to say why. So when you create the function bad square here, when you create y is x to some power and you return y, right? So how do you get the power? Here it sets the power before you call the function bad square. The bad thing about it is that the function bad square is using variable power that is here in this case would be global variable, and it's not obvious that the function bad square depends on it from the moment when you call the function bad square. Right? So it works, but not great. So if you try to make functions, try to include all the arguments in the function and don't do this. Okay? Bad square. Let's look at it and see if we can fix it. So I have here bad square that takes as one argument x, and then it calculates x to the power and returns it. So here I set the power is equal to 2, and then I calculate bad square of 4, and I print the result. Right? So in the function, the power is set to 2, and then the 4 is squared. Right? So let's see. You have 16. I can here write 5. It's 25. I can do third power if I want. So now it's 125. Right? So the code works. Right? Here are few things that one could do. So first, one perhaps should write here global power. If you have power as the global variable, it's good to explicitly say that it is a global variable. Here it is not a variable inside the function. Y is only inside the function. It doesn't exist in the main part of the program. Okay. And the bigger problem is that the bad square depends on this variable power that doesn't exist really in the bad square in a way that would be obvious. So here is a different way how you can write it. So you can write better square. Maybe it's not really a square now, but you can send in the power explicitly. Here you write y is equal to x to the power, return y. Now you call the function as 5 to 3, print result. Okay, I messed up something up, colon 125. Right? So this is a better way of how to construct function that does the same, but instead of the global variable, you are sending it in explicitly. Here is another way how to do it. If you are sure that you need to do it, then use the keyword global. So in the example, there is a x that is defined as some number, and in the function test, we say global x, which means that we want to use a variable x that was defined outside of the function test, and that we are using. And in this case, it's incrementing it by 1 and using it to modify y before it is printed. Okay? It's not obvious again that the function test changes the value of x, and it can cause a lot of headache in debugging. So if you can try to avoid using global variables in your functions. Now here is another interesting thing that happens. So I have here function add 7, right? Two ways of it. One of the left one assumes that x is a list, and it adds 7 to the list by calling append 7. The other one assumes that x is a number and adds 7 to the number. Right? So here is a interesting thing, that if you call the function add 7 that is on the left, in the end the list x will contain 1, 2, 3, 7, because the list was added or was sent to the function add 7 as a reference. What it was sent to it is saying, hey, there is a piece of memory that contains list 1, 2, 3, work with that piece of memory. On the other hand, if there is the add 7 and you use the number there over as x, then what is copied over is just the number. It's not copying over the place where the variable x lives, right? So the add 7 on the right will call function add 7 with number 2, and then the number 2 is incremented to 9, but the original x will remain as 2. Right? So be careful, you cannot modify variables that are integers or floats, but if you have things like lists, then you will be modifying them. Add 7, that will add 7 either to a list or to an integer and see what's happening with x. So make a function add 7 of x, and first I will do the list one, x dot append 7. Okay. I will make a list x is 1, 2, 3, and I called add 7 to x print x. Right? Now x is 1, 2, 3, 7. How I would expect. Now if I here print x at this in the function at 7, it shows me the list 1, 2, 3, 7. Right. I'll try to make a similar function for in integer x. So at 7 x is x plus 7, and here I write x is equal to 2, add 7 to x, x is equal to 2, print x. Right? Let's see what happens. X is still 2. If I look inside the function and write here x, then it was 9, but this x, because it's a number, it will be a local variable to the function, and it will not be the variable over here. Right? So here x is a local variable. Here also x is local, but it points to the same 1, 2, 3 as the original x. Remember, there is the reference where you have the piece of a memory where x points to, so the piece of the memory to which x points to is the same as this new x points to, right? But here you are moving over a number, so you are not moving over the reference to a list. Okay? If you would do something like x is equal to 2 and x of 0 is 7, so now you moved over a list that has one entry 2, and you change the entry in the list. It changes the entry in the list because it is with a reference. But now if you change it to move over an integer, it doesn't change it. So you should be aware of this little subtlety. Here is a interesting bonus thing, and that is recursion. Sometimes you can have a function that calls itself. Right? Here is one example for function that calls itself, and it's factorial. How can you calculate the factorial of number n? Right? So factorial of n, if n is 1, then it is 1. The factorial is 1, and the other option is that factorial of n, if n is bigger than 1, is n times factorial of n minus 1. Right? So you can write a function that will do exactly this, and it will call itself. It's called recursive function. For factorials, it's okay. You can also use it for calculating Fibonacci numbers, where n Fibonacci number is the sum of the n minus 1 and n minus 2nd Fibonacci number. But if you do that with recursive function, it will be very ineffective. So one should be careful about when to use and don't use recursive functions. Recursive function that sums numbers from 0 to n. Right? It's not the best way to sum numbers 0 to n, but maybe it will be good as a demonstration. Right? Summing 0 to n. To n. Right. So if n is 0, then sum is 0. Right? And then if I have to sum 0 plus 1 plus 2 plus n, I can write this as sum of 0 plus 1 plus 2 plus n minus 1 plus n. Okay? So I will try to use this to create the function here. So I will make a function sum 0 to n, and n is 0. Right. If n is 0, then we return 0. Right? And if n is not 0, then I will return n plus sum 0 to n, but here I write n minus 1. But if you want to have it in the same order as here, I will first sum the 0 up to n minus 1, and then I add n to it. Okay? We can try it. Print sum 0 to n of, let's say, 5, well, 15. Okay? You can here try to see. I will write print summing for n equals n. So you can see that as the function runs, it first goes with 5 in here. This is not happening, so it will call itself with 4, then with 3, with 2, with 1. So it will call itself several times and come up with 15. Right? If you really want to do sum like this, and you actually want to do the sum, you can do print sum of I for I in range now 6, because 6 is above 5, 1 above, right? You get the same thing. If you also want to do it really fast, you can do it using mathematics formula that you will write it is 5 times 5 plus 1 over 2. Bam. Right? But the point was, here I have a function that is calling itself, and it is solving the problem for n by doing a little bit of work and solving the same problem for n minus 1. Important thing is that at some point you have to make the base case where you start with some n that is trivial. This is also kind of induction. If you know what induction is, then this is a case of it. Fibonacci sequence, which is easy to write as a recursive formula, but not a good idea to do so if you want an efficient program. So let's see. Fibonacci sequence is the sequence of numbers 0, 1, 1, 2, 3, 5, 8, blah blah blah. And what's the rule? The first two are 0 and 1, and then whenever you look at the number, let's say here 8, it is sum of two previous numbers. 55 is sum of 21 and 34. If I would like to have the next number, I will sum 89 and 144. Right? Here is the definition. Fibonacci number, the nth one, is defined as if it is 0, then 0, if 1, then 1, and then fn is fn minus 1 plus fn minus 2. So here is a recursive function that calculates the Fibonacci numbers. It does exactly as the recursion. If n is 0, it returns 0. If n is 1, it returns 1. And otherwise, it returns the sum of the Fibonacci of n minus 1 and n minus 2. Right? So here Fibonacci 10, 55. Fibonacci 9, 34, right? So maybe the sync works okay, right? So it works in the sense that it calculates the number, but it is horribly ineffective. Print f Fibonacci for n equals n. Now I will try to run this, and every time the function Fibonacci n is called, we will see output. So we see that Fibonacci is called for 0, 1, 2, 3. It is called many times, right? So there is a little combinatorial explosion. So what is happening is that the same Fibonacci number is being computed over and over again. So if I want to calculate, let's say, the number 10, what I have to do is I have to calculate Fibonacci number of 9, and I have to calculate the Fibonacci number of 8. Right? And when I'm calculating the Fibonacci number of 9, I also have to calculate the Fibonacci number of 8 and Fibonacci number of 7. And when I am calculating the Fibonacci number of 8, I need to calculate the Fibonacci number of 7 and the Fibonacci number of 6. Right? So here when I am calculating the Fibonacci number of 9, I calculate the Fibonacci number of 8, and here I am also calculating the Fibonacci number of 8 when I was trying to calculate the Fibonacci number of 10. So I am calculating the same number multiple times. Right? This is very ineffective if the calculation was more demanding, or if you call it for sufficiently large, and then even the relatively simple calculation will kill your computer. Right? For your entertainment, you can try to think how to calculate Fibonacci numbers more efficiently, and by more efficiently I mean try to do it such that you calculate each number just once until you get the nth one, right? So this is example where the code, the computer code, looks kind of clean and simple, but if you actually try to run it, it will do bad things to the running time.